Hi, it's Baltazar Briere de la Hosseraye here. I am a doctoral candidate in the Building Acoustics groups in the Eindhoven University of Technology. Greetings from the Netherlands.
Hi people! In this episode, I will tell you about acoustic measurements. Of course, there exists plenty of different kinds of acoustic measurements. For example, the reverberation of a room, the vibration level near a rail track, acoustic absorption of a material, but they're basically all attempts to capture how sound and environment interact with each other. So in this video, I will focus on acoustic absorption measurements. And we do these measurements to assess how a material absorbs sound or not, so that we can use it in the best way possible to solve various acoustic problems. I will present the two main standard methods to measure the acoustic absorption and explain what are their limitations and how my project aims at overcoming these limits. So the first method is called the reverberation room method. So let's say you have a room with a high reverberation time, most likely quite a big empty room with very hard walls, in which the propagation of sound is more or less random, and it's very important. What you can do is to measure the reverberation time of this empty room and put it aside, and then you can put your sample of acoustic material inside that same room and repeat your reverberation measurement. The reverberation time will then probably be much lower than in the case of the empty room, and by using simple math, you can retrieve the absorption coefficient from this difference in reverberation. The second measurement method is called the absorption tube measurement. So this time, let's say you have a long and thin circular tube. The trick is that in this kind of tube, the propagation of the sound is usually very simple, only a plane wave in the longitudinal direction. If one loudspeaker that is placed at one end of the tube and emitting a sound, and the sample of material is mounted at the other hand, by measuring the pressure at the different location along the tube, you can retrieve the absorption coefficient of the sample placed at this end of the tube. So both methods are giving different and complementary data. The room method provides the random incidence absorption of the material, while the tube method provides the normal incidence absorption. And these are very helpful values for a lot of applications. But we still miss what happens at a given oblique sound incidence and what would happen in an environment that is not a lab. Because indeed, the room method results are always somewhat depending on the measurement room itself that you use and on the amount and how you place the material in that room. And the tube method is depending a lot on how the material is cut and mounted into the tube. And then, in order to avoid these laboratory conditions and get the effective absorption that we want to measure, it is needed to measure the acoustic materials in situ exactly in the location it is meant to be. And within Acoutect, I will be investigating what is the best way to do so, to extract all the relevant data of the material, and that presents a lot of challenges since the in situ environment is not controlled.